Hello, good day. I am Samantha Isabel B. Tupaz, and today I'm going to be talking about DSL or Digital Subscriber Line and its families, while also we're going to talk about broadband technologies here as well. So let's start off with what is DSL. This is an overview of what the DSL system is. So DSL is a technology that brings high bandwidth internet connection to homes and businesses over ordinary copper telephone lines. DSL technologies allow data transmission at speeds faster than the best available analog and digital modems. In general, most DSL connections offer download speeds between 5 to 35 Mbps and upload speeds between 1 to 10 Mbps. So now let us talk about the DSL families. The DSL families is a generic term used for a family of related technology including RAD SL, ADSL, SDSL, IDSL, and others. The leading DSL technologies being deployed today include the following. So the first one is the first umbrella term, which is SDSL, which stands for Symmetric Digital Subscriber Line. So among those systems that are included in the SDSL are the first one, RADSL or Rate Adaptive Digital Subscriber Line. Rate Adaptive Digital Subscriber Line is the most robust business DSL available today. So it is developed to overcome line impediments and distractions. It also automatically adjusts for environmental conditions because our RAD SL is a type of SDSL and it supports symmetric, which is equal downstream and upstream data transmissions up to 768K. So the second one is the IDS and digital subscriber line. It provides up to 144 kbps transmission speeds at a distance of 1,800 feet. The third one is where the umbrella term comes from, which is the SDSL, which is the Symmetric Digital Subscriber Line. So SDSL, it supports symmetric, equal downstream and upstream data transmissions up to 1.54 Mbps. And finally, we have HDSL, which is high bitrate digital subscriber line. And high bitrate digital subscriber line also provides a symmetric condition that is, as I mentioned earlier, at upstream speeds and downstream speeds are the same and they range from 1.544 Mbps to 2.048 Mbps at a distance of 12,000 to 15,000 feet. So the next one is the ADSL, which stands for Asymmetrical Digital Subscriber Line. And among the terms that are included in this is ADSL, which I have mentioned earlier, and it has a higher downstream than upstream, so the data speeds can reach up to 7 Mbps downstream and 1.5 Mbps upstream. ADSL can deliver simultaneous high-speed data and telephone service over the same line. The next one is G-Lite. This is a lower speed version of ADSL and it provides downstream speeds of up to 1 Mbps and upstream speeds of 512 kbps at a distance of 1,800 feet from the service provider's premises. It is intended to simplify DSL installation at the user's end. And finally, we have VDSL. VDSL is very high bitrate digital subscriber line. VDSL is the fastest among all of the XDSL flavors and provides a transmission rate of 13 to 52 Mbps downstream and 1.5 to 2.3 Mbps upstream over a single copper wire at a distance of 1,000 to 4,500 feet from the service provider's premises. So to sum it up, the advantages and the disadvantages of the DSL family includes the following. So the first advantage is the fact that it's affordable, as it only uses copper wires. The second one has a large coverage area. And the third advantage is it does not affect landline calls. The first disadvantage is the low speed for upstream, which was noticeable as there is the existence of, like for instance, the the asymmetric digital subscriber lines, which has a higher downstream than upstream, so it takes a longer time to upload stuff. And then for disadvantage number two, it's distance sensitive, which has been shown to be a problem, as some DSL families tend to not overcome line impediments, unlike the RADSL. And finally, it is susceptible to electrical noise. So now let's talk about broadband technologies. What are broadband technologies and where do we use them right now? So broadband technologies, uh, it is a large range of communication technologies with different technical capacities. So we often use it. We often hear the word broadband when we talk about our internet connections, our internet service providers, and that is exactly what we are going to talk about today. So the first one is the wired broadband technologies. So wired broadband technologies include copper cables, which was DSL that I have mentioned earlier, coaxial cables, BPL, and optical fiber cables. So first of all, we have copper wires. Copper wires are defined as legacy telephone unshielded copper twisted pair. So they have provided broadband connections using the XDSL technologies that we have mentioned earlier, and they have these multiple pros and cons. So the first pro for copper wires is that they require relatively low investment needed for passive infrastructure. So it's because we usually see copper telephone lines in our households, and they are the least disruptive for the end users. So the cons is that there is high download speed. The high download speeds depend on the length of the copper wire. So the XDSL technology is heavily asymmetrical, as seen earlier. Asymmetrical technologies for the DSL technologies has been provided early first before the symmetrical ones. So upload speeds are generally much lower than download speeds. So they hamper new services such as cloud computing, video conferencing, teleworking, and telepresence. So there is a much higher investment needed in active equipment. So so copper wires may be an interim solution, but the investment of fiber infrastructure would would actually be better. So the next one is we have the coaxial cables. This is the classic cable connection, which would be the two wires of a telephone line. So this is actually also the most prone to disturbance effects such as interference. Broadband internet via coaxial cable is actually offered to customers with existing cable TV. In the Philippines, among this would be Sky Cable and Signal. So the coaxial cable consists of a copper core and a copper shielding coat. The TV cable networks are therefore much more efficient than the traditional telephone networks. So there are pros and cons for this as well. Pros first is that this requires relatively low investment needed for passive infrastructure, and it is also least disruptive for end users, as I mentioned earlier, as it uses existing cable TV. This infrastructure offers slightly more opportunities to deliver high broadband speeds than on telephone lines. So, ultra fast speeds are also possible if the infrastructure is properly upgraded. Now, for the cons of this one, the bandwidth is shared among several users, reducing its availability during peak traffic periods of the day. So, if there are a lot of people using it, the bandwidth will be shared. So, the connection that you will get from for your device is not as fast as it should be. So the impossibility of unbundling makes service competition basically absent in the cable market. Now, let's talk about broadband over power line, which is BPL. This is the case wherein broadband can be delivered on over existing low and medium voltage electric powered distribution networks. These is comparable to both XDSL and coaxial cables. So the pros here, like the first ones, was it was not necessary to deploy new infrastructure as existing power lines can be used. So, and the cons of this one is that in low populated areas, technology is only economically viable for the end user if 4 to 6 homes are equipped with transformers to make broadband available over power lines. So, so that is a big con for BPL. The last one is optical fiber. And optical fiber lines consist of cables of glass fiber connected to end users' homes, buildings, or street cabinets. We usually call this fiber. They allow for very high transmission rates, and this is the most future-oriented solution, but it also requires high investment in passive infrastructure. So the pros here is that it has an extremely high level of transmission rates and symmetry, and it is less susceptible to interference and hardly any power drop at larger distances to the distributor, unlike DSL or VDSL, and enough power reserves also for demanding multi-person households. Now, cons for this one includes high investment costs in passive infrastructure due to the high costs of civil engineering for excavation and piping. Deployed infrastructure is not locatable and requires exact documentation. So, those are the ones where we use wired broadband technologies. Now, let's talk about wireless broadband technologies. This include mobile radio solutions such as HSPA, LTE, fixed radio solutions, and satellite solutions. So the first one is for antenna sites for wireless connections. We always see this uh, in Wi-Fi or 4G slash LTE or LTE advanced solutions. So, so the first pro of this is that the first mile wire connections are needed, so they can be used for commercial mobile services. But the cons for here is that since the bandwidth can be shared among several users, it also slows down at peak traffic periods of usage. So signal strength decreases fast with distance, and it is affected by the weather. So, the next one is satellite broadband, also referred to as internet by satellite, is a high-speed bidirectional internet connection established via communication satellites located in the geostationary orbit. The end customer sends and receives data via a satellite dish. Oh, this is usually located on the rooftops. So one of the pros here is that it requires low investment for passive infrastructures because, as I mentioned, it only requires data via satellite dishes. And the cons here, however, is the limited total of number of users can be covered in one region. So it has inherently high signal latency due to the propagation of time to and from the satellite, so it hampers certain applications. Now, let's talk about the upcoming broadband technologies. So the first one is we have 5G. 5G is the next phase of mobile telecommunication standards beyond 4G and LTE. So it allows for an application end-to-end latency of 4 to 1 milliseconds according to the ITU, and it is said to be capable of at least 10 Gbps upload and 20 Gbps download data transmission rates. So the pros here is that 5G offers improvement in coverage, signal efficiency, and transmission rates. So, and the cons here is that most of the services are not yet in need of high-speed data transmission rates. So, but this can change as the applications evolve as well. So the next one is the LEO satellites or low Earth orbit satellites. So these are satellites that circulate closer to the Earth. So as these satellites circulate closer to the Earth, it will also allow for better web performance, and it can cover wide areas and enable affordable broadband access. So, so the pros here is that MEO, which is medium Earth orbit satellites, and LEO satellites are featuring lower latency. They can cover wide areas and thus facilitate broadband coverage for very rural and remote areas. So the cons here is that a big network of satellites launched in the orbit is necessary in order to cover most areas of the planet. This in turn produces high costs for supplying in the companies. Now the next one is internet balloons, wherein these are sent up 20 kilometers into the stratosphere. Specific software moves them up or down to find the right winds to direct them into position. Each balloon beams an internet connection down to the antennas of the ground. So this is actually called the Project Loon. and it is a network of solar powered balloons transmitting internet signals to ground station homes using LTE technology. So the pros here is that internet balloons are capable of bringing internet access to the most remote parts of the planet. AI algorithms ensure that the balloons find and exploit the optimum wind flows to stay longer in the air. And the cons here is that the enormous coldness adds to the nylon material of the balloon and makes it brittle. Lubricants become tough at these temperatures, and the balloons are exposed to strong ultraviolet and cosmic radiation. The last one that is mentioned is the light fidelity or Li-Fi. So Li-Fi is a bidirectional high-speed wireless communication technology that uses visible light communication or infrared and near ultraviolet spectrum. So the light emitting from LEDs serve as the medium to deliver communication. Now, Pure Li-Fi is a company that demonstrated the first commercially available Li-Fi system, which is the Li-First. There are now a few number of companies that are developing this technology. So among the pros here is that Li-Fi is 100 times faster than Wi-Fi, reaching speeds up to 224 Gbps. So this is very useful in electromagnetic sensitive areas such as aircraft cabins, hospitals, and nuclear power plants without causing electromagnetic interference. Additionally, Li-Fi is expected to be 10 times cheaper than Wi-Fi. So the cons here is that the technology only delivers communication over a short range. Low reliability and high installation costs are further potential downsides. So, so again, that's all. Thank you very much for listening and see you again soon.